This is SpaceTime, Series 28, Episode 15, for broadcast on the 3rd of February 2025. Coming up on SpaceTime, the building blocks of life discovered on the asteroid Bennu, a new asteroid threat to planet Earth, and a new mission to investigate a group of mysterious domes discovered on the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered the molecular building blocks of life in samples of the asteroid Bennu brought back to Earth by NASA's Osiris spacecraft. The findings, reported in the journals Nature and Nature Astronomy, also show a history of salt water on Bennu, and that could have served as a sort of broth for these compounds in order to allow them to interact and combine. The findings do not show evidence for life itself, but they do suggest that the conditions necessary for the emergence of life were widespread across the early solar system, and that increases the odds that life could have formed on other planets and moons. NASA's Osiris sample return mission has already rewritten the textbooks on what science understands about the beginnings of our solar system. Launched from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket back on September 8, 2016, the 2,110-kilogram Osiris spacecraft arrived at Bennu in October 2018. The probe spent the next 3 years orbiting the asteroid, often getting down to altitudes as low as 5 kilometers, mapping Bennu's surface and geology, studying its evolution, its composition, its chemistry and mineralogy, and then finally touching down on Bennu's wild, craggy, boulder-strewn surface in order to collect samples before returning to Earth. It's a carbonaceous Apollo group asteroid. That means it's a NEO or near-Earth object with an orbit that intersects with and crosses Earth's orbit around the Sun. The 492-metre wide space rock currently has one of the highest known chances of hitting the Earth, with a 1 in 2,700 chance of impacting our planet sometime between 2175 and 2199. Now, if it were to hit the Earth, the resulting impact would be the equivalent of 1,200 megatons of TNT. And making matters worse, its orbit is intrinsically dynamically unstable. Asteroids are sort of like time capsules into Earth's early history, and Bennu samples are pivotal to science's understanding of what ingredients in the solar system existed before life on Earth began. These new results are among the first really in-depth analyses of minerals and molecules in the Bennu samples, which Osiris delivered back to Earth in 2023. The findings in the journal Nature Astronomy include news on the most compelling detection so far of amino acids. In fact, they found 14 of the 20 that life on Earth uses to make proteins, and all 5 nucleobases that life on Earth uses to store and transmit genetic instructions in more complex terrestrial biomolecules such as RNA and DNA, including how to arrange amino acids into proteins. The authors also described exceptionally high abundances of ammonia in the Bennu samples. Now, ammonia is important to biology because it can, given the right conditions, react with formaldehyde, which was also detected in the samples, and together they form complex molecules such as amino acids. When amino acids link up in long chains, they make proteins, which then go on to power nearly every biological function. Now, these building blocks for life detected in the Bennu samples have been found before in other extraterrestrial rocks. However, identifying them in a pristine sample collected from deep space supports the idea that objects that formed far from the Sun could have been an important source for the raw precursor ingredients of life throughout the solar system. One of the study's authors, Danny Glavin from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the samples being examined were minuscule and they could have easily been destroyed or altered were they exposed to an Earth environment. Some of these new discoveries could simply not have been possible without a sample return mission, without meticulous contamination control measures, and without careful curation and storage of this precious material. While Glavin's team analysed the Bennu samples for hints of life-related compounds, their colleagues, led by Tim McCoy, curator of meteorites at the Smithsonian's National Museum of Natural History in Washington, D.C., and Sarah Russell, a cosmic mineralogist at the Natural History Museum in London, looked for clues to the environment these molecules would have formed. And their research, reported in the journal Nature, describes evidence of an ancient environment well suited to kickstart the chemistry of life. They identified traces of 11 minerals ranging from calcite to haltite and sylvite in the Bennu samples that form as water-containing dissolved salts evaporate over long periods of time, leaving behind the salts as solid crystals. And the thing is, similar bryons have also been detected or suggested across the solar system, including on the dwarf planet Ceres and the Saturnian ice moon Enceladus. Although scientists have previously detected several evaporites in minerals that have fallen on Earth's surface, they've never seen a complete set that preserves an evaporation process that could have lasted thousands of years or more. Some Bennu minerals, such as trona, were discovered for the first time in extraterrestrial samples. McCoy says the findings go hand in hand in trying to explain how life's ingredients actually came together to make what scientists see on this aqueously altered asteroid. But for all the answers the Bennu samples have provided, several key questions remain. See, a lot of amino acids are created in two mirror image versions, sort of like a pair of left and right hands. And here on Earth, life almost exclusively produces only the left-handed variety. But the Bennu samples contain equal amounts of both. And that means that on early Earth, amino acids may have started out in an equal mixture as well. The reason life on Earth turned left instead of right remains a mystery. Another member of the team studying the Bennu samples is Associate Professor Nick Timms from Curtin University. He says the discovery of the salts was a breakthrough in space research, and he was surprised to identify the mineral halite, which in simple terms is sodium chloride, exactly the same salt that you may put on your fries. These minerals come from the evaporation of brines, a bit like salt deposits forming in salt lakes on Earth. Tim says by comparing the Bennu samples with mineral sequences from salt lakes on Earth, scientists can start to envisage what it was like on the parent body of the asteroid Bennu, in the process providing new insights into ancient cosmic water activity. Evaporate minerals and brines are known to help organic molecules develop on Earth, and Tim says a briny carbon-rich environment on Bennu's parent body was probably suitable for assembling the building blocks of life.
We found salt minerals, about 11 different salt minerals in the particles from Bennu, and that's quite a significant finding because we don't tend to find salt minerals in the meteorites that have made their own way to Earth. And so it's a kind of a rare finding because these minerals are very delicate and they're probably preserved because they hadn't interacted with Earth's atmosphere and biosphere because the sample has been returned to Earth in a sealed capsule. So this pristine sample has provided the opportunity to be able to identify these in this really primitive material from the solar system. The significance here is that these minerals, the salts, form from a process of evaporation from brines, which is not what we expected to see, I don't think, in this material. And it gives us a clue as to some really ancient activity of the salty water in really early on in the solar system.
And some of these salts include sodium chloride, table salt.
Yeah, table salt. Yeah, we found very tiny particles, broken fragments of halite, sodium chloride in the particles here at Curtin University. And that's really special because I think in the entire meteorite collection on Earth, which is numbers, tens of thousands, the sodium chloride has only been seen in 3. So it's a really rare thing. But it's principally because, as we know, salt dissolves and it's very unstable. And the other significant thing is that sodium chloride forms when you have a really high proportion of evaporation of a brine as well. So we can look at all of the different minerals that we've discovered in the sample from Bennu and then start to build up a picture of how much evaporation there was and what kind of fluids were involved, how alkali they were at the time, which is really key.
I take it we're not talking about a salt lake evaporating in the sunlight here. We're talking about moisture soaking up from underneath and then sublimating into the vacuum of space.
Yeah, it's unclear exactly what the liquid water bodies would be like on the parent body for Bennu. It seems a little bit far-fetched that there will be salt lakes like the ones we have in Australia. It might be a lot more small pockets of fluids, possibly on the surface of the asteroid, but maybe also in cracks and fractures that have been replenished by the expulsion of fluids from deeper within the parent body. Something we don't know for sure. We can only speculate and guess. But nevertheless, the actual presence of all of these minerals indicate that there must have been liquid water with dissolved salts in them present on the parent body for asteroid Bennu.
We've seen salts before in space, haven't we, in places like Enceladus?
Yeah, absolutely. So Enceladus, Saturn's moon, and the dwarf planet Ceres as well, which is in the asteroid belt between Mars and Jupiter, are both icy bodies in our solar system, and they're beautiful bodies. And within them, beneath the icy surface, there are proposed to be brine oceans, actually. So, yeah, salts are very present on those two bodies particularly. And even the spacecraft flyby of Enceladus was able to see plumes of material kind of erupting from the icy surface of Enceladus, and salts were detected in those plumes. So we know that they are present on those bodies, and so they are very interesting. I think there's a very strong scientific case to investigate those two bodies more to see if we can see more, find out a lot more about them.
The amino acids are interesting too, aren't they? Looking at the other side of the equation there, that says a lot about just how ubiquitous they are throughout the solar system, and I guess throughout the cosmos, really.
Yeah, absolutely. So our colleagues have been spending a lot of effort trying to identify all of the organic molecules and compounds in the sample from Bennu. And there's an impressively large array and wide variety of them. Amino acids being one, and also nucleobases and all sorts of other things. And all of the ingredients that make up terrestrial life as we know it, and components of RNA and DNA too. And to think that those were able to have formed very early on in the solar system on very early bodies is quite impressive, really. And it might mean that those building blocks of life that could have been delivered to Earth are a lot more common and a lot more varied than we previously thought.
Here on Earth, wherever you find water, even if it's 1,000 meters underground, you'll find life. Life has a way of inhabiting these areas, no matter where they are on this planet. That must spark the imagination somewhat.
Yeah, absolutely. And we know that life is pretty much ubiquitous on Earth, but we have never found life on any other body, and that includes this asteroid Bennu. We're not saying there is life there. We have never been able to detect life from remotely on any of the other bodies as well. But given the fact that the brines and salts are actually catalysts to polymerizing and creating some of these prebiotic amino acids and other organic molecules and compounds, where we get salty brines and a carbon and nitrogen-rich environment, we might expect to see all of the ingredients for life. And so our eyes naturally point to where we know there are brines. And so Enceladus and Ceres, with their briny oceans, could be a strong candidate for somewhere that could have developed life, whether it's there now or has been there in the past or was never there. We need to, I think, find out. That would be fantastic.
And let's not forget the red planet Mars. That may have brines as well. Not sure, but that's still a possibility, because if there is liquid water on the surface of Mars, considering the thin atmosphere there and the temperatures, it would only survive in a liquid form if it was a very thick brine.
That's true, and there are some very tantalizing pieces of evidence seen by the rovers of the existence of water on the surface and brines and so on. But we also know that just beneath the surface on quite large areas of Mars exists ice as well, water ice. Yeah, so and exactly how salty some of that material might be, or whether there are variations in around that permafrost, would be really interesting to find out too.
With everything that we now know about Bennu and Enceladus and Ceres and Mars, what should be the next step?
Oh, that's a really good question. I think,
if you had a NASA budget.
If we had an unlimited budget, imagine, and put the best scientists to the task to come up with amazing plans to go and test to see if any of these places harbor life or could harbor life, then I would love to see missions that would actually go to and visit Enceladus and Ceres, and also investigate more some of the really tantalizing places on Mars.
What are some of the other results that have been coming from these samples you've had a chance to look at from Bennu that have really sparked your imagination? You've looked at them and said, oh, that's fascinating. I didn't expect that.
Well, some of the analyses that have been done by the sample analysis team looking at the bulk chemistry is really fascinating. The abundance of elements in the bulk sample of Bennu is almost identical to that of the abundance of elements in the photosphere of the Sun. What that means is that the material that accreted to make Bennu didn't undergo differentiation like we have on Earth, where things go to the core and some things stay in the crust and so on. It means that it's been unaltered for all of this period of time. And it's very, very similar to solar composition, which is just astounding. It's really incredible. Another amazing thing are the isotopes of nitrogen, oxygen, and carbon. For example, the recent study, which incorporates all of the organic molecules, also has some data in there that shows a really strong anomaly of 15 nitrogen, the isotope, and anomalous isotopic composition of nitrogen like that, and a really high abundance of ammonia suggests that the ices that accreted to Bennu really were sourced from the outer solar system, which is a really interesting possibility because Bennu, the asteroid, is no longer in the outer solar system. So we can sort of start fingerprinting where the material came from in the solar system to make the parent body for Bennu, and then also we can start thinking about, well, how did a body out there break up and then become, or a fragment of it become asteroid Bennu, which is a much more closer orbit to the Sun.
Well, it's an Apollo group asteroid, so it's an Earth-crossing asteroid. In fact, it's one we're keeping a very close eye on because there's a 1 in 2,700 chance of it impacting the Earth sometime around 2175, 2199, thereabouts. So it's one we're watching, and we know its orbit's unstable.
Yes, absolutely. And like Apophis, which is what the Osiris-Rex spacecraft, once it dropped off the capsule with the samples from Bennu, has now jetted off to Apophis to go and survey Apophis, which is another near-Earth object and that poses a small probability of an impact to Earth. In fact,
whether it goes through that keyhole in space or not.
Yeah, exactly. But just breaking news is another asteroid that's been identified, YR4, which is a 100-meter wide asteroid, which also has a chance of hitting Earth in around 2032. So I think all eyes are on that one at the moment in terms of finding out more about its orbital dynamics and to see what the risk is as we find out more about it.
That's actually our next story on the show, so thank you for that.
There you go. Perfect segue.
That's Professor Nick Timms from Curtin University. This is Space Time. Still to come, that new threat to planet Earth Nick Timms talked about, and a new mission to investigate mysterious domes discovered on the Moon. All that and more still to come on Space Time. Astronomers have detected a near-Earth asteroid which could pose a potential threat to our planet. The space rock, catalogued as 2024 YR4, is between 40 and 100 metres wide and has a 1 in 83 or 1.2% chance of crashing into the Earth on December the 22nd, 2032. That's one of the highest known probabilities of Earth impact of any known celestial object. The asteroid was first discovered by the Asteroid Terrestrial Impact Last Alert System ATLAS on December the 27th. Based on 34 days of observations, astronomers have calculated the asteroid made its last close approach to Earth just 2 days before its discovery, coming to within 828,800 kilometres of the planet's surface on December the 25th. This Earth-crossing Apollo-class asteroid is now moving away from our planet in its orbit and is already too faint to be observed by most telescopes. It makes its next close approach on December the 17th, 2028. Now, early calculations suggest rather than a direct impact in 2032, a near miss is more likely, at a rough distance of roughly 106,200 kilometres. But what if it didn't miss? What if it was a direct impact? Where would it hit? Well, the most likely trajectory for a potential Earth impact is somewhere along an arc stretching from the Central Eastern Pacific Ocean across northern South America, then across the Atlantic Ocean and equatorial Africa, before finally dissipating in northern India. Exactly where along that arc an impact's likely to happen, if it's likely to happen, is anyone's guess at this stage. Now, with a space rock between 40 and 100 metres wide, the impact is likely to cause a powerful airburst explosion in the atmosphere, or possibly, depending on its exact trajectory, it could even impact the ground, leaving a crater. Astronomers are sufficiently concerned to see 2024 YR4 hit the top of the European Space Agency's NEO impact risk list, and it's also well up there on NASA's Century risk table. Needless to say, we'll keep you updated. This is SpaceTime. Still to come, a new mission to investigate mysterious domes discovered on the Moon, and later in the science report, the Central Intelligence Agency, the CIA, says COVID-19 likely did come from a lab in Wuhan, China. All that and more still to come on SpaceTime. NASA is planning a new mission to study mysterious dome-like structures discovered on the Moon. The research will be included in the agency's Lunar Vice mission by Firefly Aerospace. It's designed to better understand the Gruthusum domes, one of the most enigmatic locations on the Moon. The Lunar Vulcan Imaging and Spectrographic Explorer, or Lunar Vice mission, aims to investigate these domes' inexplicable origins and whether the Moon's surface contains potential resources for future lunar exploration. The mission's instrument project scientist Jessica Sunshine from the University of Maryland says the mission represents a major milestone in efforts to learn more about the Moon's volcanic history and evolution over time. Now, Lunar Vice is currently still in its developmental phase. It's slated for a 2028 launch date. It'll travel across the Gruthusum domes on the near side of the Moon for about 10 days. One of its primary goals is to investigate how these silica-rich volcanic domes first formed, a process that remains a mystery to scientists because of the Moon's lack of Earth-like conditions, such as oceans and plate tectonics, which help create similar features here. The instruments aboard Firefly's rover will also conduct detailed studies of the lunar surface in the area, looking at ancient lava flows surrounding the landing site and other important geological features which could help scientists reconstruct the Moon's history from its formation through to its current state. Sunshine says that for much of the first half of 2025, the Lunar Vice team will be assembling, testing and calibrating flight instruments for the upcoming mission. That'll include the visible and near-infrared cameras which will be used to detect electromagnetic waves for remote sensing and imaging. The team hopes to complete the final testing of components by August. That'll ensure they'll meet all operational requirements and safety standards for lunar deployment by the project's launch date. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A Central Intelligence Agency assessment of the origins of the COVID-19 pandemic has found that it's likely to have originated from a laboratory leak at the Wuhan Institute of Virology. However, the CIA report, which was prepared during the Biden administration, claims the assessment maintains a low degree of confidence because the Chinese government cleaned out and destroyed most of the evidence. The assessment was based on analysis of existing intelligence related to the virus's characteristics, its initial spread, and the working conditions in China's virology lab, leading up to the conclusion that a laboratory origin is more likely than a natural origin based on all the available information. Importantly, the CIA's findings align with the United States House Oversight and Accountability Committee's findings, the US State Department's findings, the FBI's own conclusions, and the US Department of Energy's assessment, all of which consider a lab leak as the most likely source of the virus. The World Health Organization says over 7 million people have been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the Lancet Medical Journal estimates the true death toll likely to be above 18 million, with some 775 million confirmed cases globally. A new study claims that elderberry juice may be a potent tool for weight management and enhancing metabolic health. The findings, reported in the journal Nutrients, found that drinking 12 ounces of elderberry juice daily for a week caused positive changes in the gut microbiome, improving glucose tolerance and fat oxidation. Elderberry, a small dark purple fruit found on elder trees native to Europe, is commonly used to promote immune function. The authors tested the effects of elderberry on metabolic health in a randomized placebo-controlled clinical trial with 18 overweight adults. Participants who consumed elderberry juice had significantly increased amounts of beneficial microbes. Now, in addition to positive microbiota changes, the elderberry intervention also resulted in improved metabolism. The results showed that the elderberry juice reduced participants' blood glucose levels by an average of 24%, indicating a significantly improved ability to process sugars following carbohydrate consumption. And the results also showed a 9% decrease in insulin levels. The trials suggest that elderberry juice can enhance the body's ability to burn fats. Paleontologists have discovered part of a feathered dinosaur tail preserved in a piece of amber. The amazing discovery, reported in the journal Current Biology, was made in the Burma marketplace. The feathered tail segments, which date back some 99 million years to the mid-Cretaceous period, belong to a juvenile dinosaur no larger than a sparrow, the unfortunate dino becoming trapped in tree resin. But the event ultimately preserved a 36mm segment of the tail, complete with bones, flesh, skin and feathers. The authors suspect the tail belonged to a two-legged bird-like dinosaur called Maniraptoran. Detailed examination showed the feather pigmentation featured a chestnut-brown upper surface with a pale or white underside. Now that's a pattern still used by life today, known as countershading. A new study by the Hebrew University in Jerusalem has looked at an innovative measure of public attention based on UFO reports. The study shows a potential and surprising link between these sightings and economic conditions at multiple levels across the United States. The findings reveal a new way to study macroeconomic behaviour and thereby inform policy, especially in managing regional economic responses and addressing variations in public attention during periods of economic uncertainty. But Tim Mendham from Australian Skeptics says the study also has its detractors.
This is a theory that comes out of a university in Israel, in which he suggests there's a link between an interest in, a belief in UFOs, UAPs, etc., and economic circumstances. Sometimes these things read as if you change the economic circumstance, you will change the belief.
Does that mean if you're a hillbilly, you're more likely to be probed?
More likely to think you've been probed? The answer is...
Point taken.
Not necessarily, according to this research. It's suggesting that there's a higher level of interest in and belief in UAPs amongst wealthier countries than amongst poor countries or poor sections of society.
Because they're trying to survive.
The poor people are trying to survive, yes. One of the issues there is, of course, rich people have more time, is what these say, and that more time to stare at the sky and see things they don't know what they are. Also, there's more education, more communication, especially the wrong sort of communication, promoting UFOs, etc. So that might be an indicator.
It explains the royal family's interest, doesn't it?
It does a bit, yeah. I don't know how much spare time they got, but not a lot of qualifications. This research, therefore, has a bit of an each way, saying, yes, there is probably an element of personal stress, making you believe in things. There's also more time to believe things and more time to look at the sky. Others have criticised the research and said, no, it really is stress. And they make the point out during times of upheaval, pandemics, wars, recessions, conspiracy theories abound, mainly because you've got uncertainty. That's true, we found that, but it's also the more information sources, the more sort of conspiracy you're going to come across. But they're suggesting that people hate uncertainty. Yep, they do. They don't like it. People hate being out of control or not able to control their own destinies, which is linked to the uncertainty. But they don't like other people doing it, so that raises conspiracies, etc. So there could be a lot of reasons why people believe in UFOs. It might just be coincidental with economic conditions or economic circumstances. I would have little trust in a causal link between the two.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.